Bem-vindos ao Type Theory for All podcast. This is your host, Pedro Abreu, and in this episode, I invited my close friend and former roommate, Eric Bond, to talk about some really cool projects happening in the realm of programming languages, theorem provers, and software verification. Eric works for a consulting company and functional programming called 47 Degrees. 47 Degrees also organizes Scala Days in Lambda World, and this is just one of the few things we talk about in this episode. So let's get into it! Welcome everyone. Today with me, I have my very close friend, old roommate, former roommate. Yeah, pardon my English, I suck, yeah. I know. Eric Bond! Welcome, man.
Hey, awesome. Pleasure to be here.
How you doing?
Pretty good. You know, just staying inside as I have been.
Yeah, kids, stay inside. It's still COVID era.
Yeah.
Everything is inside. Dude, I can't wait for when I can actually, go to conferences and, be face to face to people and do these podcasts with actual people, not just Zoom people. You're just Zoom person right now.
Zoom. I just live in the society of Zoom.
We all do. So anyways, I'm going to tell this little cute story of how we met, because you used to be here actually, right? You were here in Lafayette. We were happy together.
Yeah.
Yeah. We shared advisors. We were both working on Cedille. Everything was nice. And well, we went to Portland. We were roommates. We had some really good food over there. Do you have anything to say about that?
Grassa. If you're in Portland, Grassa. That's the place.
Oh yeah. And I have something else to say as well. Chicken peanut curry.
Oh, absolutely. I you know what? I would be so sad. I hope those places, are there after all this. I'd 100% go and support.
Right. No, but actually, as soon as we left there in 2019, they closed the second square of food courts, right?
That's right. It was to build some, I think it was a hotel or something. Or Ritz? Yeah. I don't know. Some big name hotel.
Jesus. That was horrible. Was horrible. Anyways, if you're in Portland, make sure you go to the, what's the name? Food square?
Food carts. They're like
food carts.
Yeah.
Food carts.
All of them. They're so good.
They are.
Yeah. Interning at Gawa, that was a huge benefit that I didn't even know about, was just being so close to all those food carts.
I don't think I ever asked you this. How did you like that internship?
I really enjoyed it, and to be able to like hang out and play snooker with some of these awesome people who publish in like papers on type theory and functional programming languages, it was just a really cool environment to be in.
Yeah, and they're working on some amazing projects involving not only functional programming but also formal verification. Many of them, right?
Oh, absolutely. And they're known as like really good Haskell shop. Like, oh my gosh, their code is intimidating.
They are. No, yeah, actually, if you look into the code base of Crucible, for example, well, we're going to talk more into details about this later, but Crucible is probably one of the most fancy Haskell codes out there. Like they use all sorts of language extensions, and it's just wild, insane, right?
Yeah, it gets crazy when you see the language extension imports and you got like 12 lines at the top of your file. It's like, oh, this is going to be a wild ride.
Well, we'll get there. Yeah. Let's talk about how. So you after that internship, you decided to drop your master's and go for the industry. How did that go? How did you make that decision?
Well, so I was dating at the time, and I wasn't exactly sure. There was a couple of different things. I was dating at the time. I wasn't exactly sure what I was going to do after my master's. It was pretty much looking like I was going to go into work, and so I started hunting around, and I was like, okay, well, I've done formal verification stuff in school. Where's this stuff in industry? And so currently I am at a functional programming consultancy called 47 Degrees, and we work in Haskell, Kotlin, and Scala. And it's been a really fun time trying to bring the Church of Functional Programming to the audience of industry.
Church of Functional Programming. I love that. That's great. That's great.
It's Alonzo Church's Church of Functional Programming.
Great way to put it. Great way to put it.
Yeah.
So what do you do there? What is your work, man?
So we're half in the US and sort of half in Europe or so. I take sort of contracts that come in based on like the expertise that people are looking for. So it'll be like a few, me and a couple members, like 47 consultants, will go work for a company for maybe a few months or something. And when we get there, we try to encourage best practices for them in terms of how to best use, for me, Scala, how to do functional programming in Scala, how to make your code safer, how to make your code easier to reason about. And we teach them... right now, we're actually running a book club on the Red Book. It's the Scala and functional programming book for a company we're contracting to. So it's fun stuff like that. I actually had not really worked in Scala beforehand. It's sort of interesting because it cribs a lot from Haskell. And I think it's this kind of it's this nice compromise between being in the Java JVM where you've got millions and millions of developers working on all these things, and then also having the type system similar to Haskell. Is not as strong, but you can still do some pretty awesome things with monads and stuff. It's been an interesting experience. Yeah.
Oh yeah, I definitely agree. I think Scala is an amazing language that tries to kind of take the best of all the worlds.
Yeah.
Sometimes it can get a little messy if you're
my goodness
careful with what you're doing. That's for sure. Yeah. But if you are careful and you know what you're doing, and you have some discipline to apply all these cool things that you can, so like pretty much have all the functional programming cool stuff that you can get.
Yeah.
You have all the cool stuff that you can get from OO as well, and so basically best of functional and imperative language. Yeah. And on top of that, you can reuse everything that is already done in Java because, the JVM. JVM is beautiful. JVM is awesome.
Yeah, and there's just so many libraries there. I mean, and there's a lot of people that are in this functional Scala ecosystem that will take an existing Java library and then wrap it into like a stack of monad transformers and try to make it more, abstract away the effects, make it pure, give you a nice functional interface, so you don't have to deal with the dirty bits of Java light code.
Yeah, for sure. Correct me if I'm wrong here, but if I understand it correctly, so 47 Degrees is basically a contractor company that is hired for advising on how to better organize projects functionally.
Yeah. So we've done work for like Nike or Microsoft or Peloton and stuff like this. Yeah, but so sometimes we'll come in for consulting. Sometimes we'll come in for like team augmentation, where we're just like it's like you're temporarily working for a company. It's kind of like an internship. You go in there.
How's that working with all the quarantine stuff? Like you cannot actually go there.
Yeah, that's been interesting. The client I'm working on now, I had one in-person meeting when we were sitting down trying to work out the details of the contract, and then boom, lockdown happens. And I've worked with these people for almost a year, but I've only seen them in person once. It was
oh man.
Yeah.
I have some friends looking for internships right now, and I'm like, dude, this is such a bad time for doing internships, right? Because I think the most value you get out of internships, it's pretty much the network, like we were doing at Galois.
I mean, those pinball scores, you're racking them up.
Shut up, but don't tell them.
That's what you should tell them.
Oh yeah, no, yeah. I tried my best to beat Joey on that pinball, Joey Dodds, but man, he's too good. I know, actually, I got to a point where I think I could beat him, but it would take me like 2 hours straight of gameplay. 2 hours in front of the pinball machine playing a perfect game, and then you would beat him. But I'm like, Jesus, I just give up. No, I'm done. I got where I wanted,
Yeah. Oh man.
So anyways, moving forward. Okay, so 47 Degrees is pretty cool. They're doing some really cool work. Wait.
Actually, one other thing, we also run conferences too.
Oh, really?
Yeah. Lambda days and or sorry, Scala days, and
Mm-hmm.
well, obviously not these most this most recent year, but
You didn't hold it online like
no,
everyone else?
unfortunately not. Yeah. That has been, I'd say, one benefit of this pandemic though, is having all these conferences accessible and being online.
So do you guys work? What are the other languages do you guys work with other than Scala?
So Haskell and Kotlin. Our Haskell efforts are mostly led by Alejandro Serrano.
Hmm.
And I know he I think published recently on, I think there was a paper with Simon Peyton Jones on something to do with Haskell type system, like quantifiers. I can't remember exactly what it was, but no, he's been working with 47 degrees for a while now. He's been leading our Haskell efforts, and we also run this thing called the 47 Degrees Academy, and so he's been creating content and classes on what are monads.
So it's like online classes
Yeah,
for,
yeah,
Haskell.
yeah.
Is it free or is it paid?
Well, they have a couple ones. A couple ones of them are free, but they also do offer like paid ones where you can come in and get more time and more hands-on tutorial stuff.
Right.
Yeah,
That's really cool. That's
yeah,
amazing stuff. It's very exciting to see all these initiatives being put forward in functional
yeah,
programming because it's basically, we are here doing all this cool research and we're trying to push the boundaries of what are the cool stuff that we can do with our programming languages. But it took a while to start growing and people start using and having actual companies making money out of these cool ideas, right?
yeah. Well, one of the talk about Haskell and application. One of the projects that he was working on was, we have a framework for building functional microservices called Mu, and we have a Scala implementation and a Haskell implementation. There's actually a cool experience report that he and one of our other coworkers published, but it's interesting to see. Well, here, okay, we know academic Haskell, like messing around with the types, but what happens if you need to like write microservices with this thing? What do you do? What kind of what does Haskell as a language give you in terms of features? And they do all these really cool things with like type level schemas and sort of like generating serializers and deserializers and stuff like that, and which Haskell makes that stuff much easier than trying to bolt it onto other languages.
What's type level schemas? I don't think I've ever seen that.
You know what? I'd have to refer to I'd have to refer to their project. I have not cracked open a can of worms yet, but
I'm putting you on the
yeah,
spot here.
yeah. Well, so I can say that they abuse Haskell's type literal system. So you know how
Mhm.
you can you can lift like natural numbers and like yes, like strings as
Yeah.
types.
Yeah.
Well, they basically do that with like records and stuff.
Oh, wow.
So like the actual schemas, and yeah, so
Mhm.
it's
Okay.
yeah.
Okay.
And so your your values are instances of the schema.
So, anyways, as we were saying, there is this very cool transition where many companies are starting to actually profit from
Hmm.
these really cool ideas in functional programming, and not only functional programming, but the whole idea behind formal methods, behind
Hmm.
verification, behind SMT solvers, and all of
Oh
that.
yeah.
So the whole idea that why I wanted to invite you today is because since you are in this, you are, like in the eye of the hurricane, you
Yeah.
are you are actually talking with all these different companies and talking with different peoples in this very rich scenario in the company over there. So I wanted to invite you today so that we can talk a little bit about all the cool projects work happening in PL, happening in verification, that uses idea behind type theory, like these cool ideas applied in practice.
Oh
And
yeah.
we could come up with quite a few really cool projects that we want to go through today. But the basic languages that we believe that are very important and worth to mention, and
Yeah.
by no means we're going to be comprehensive in this list because
Yeah.
there is there are so many cool languages out there nowadays, but we try to focus on the biggest ones. And I really hope that this is not going to make anyone upset if we left anything behind, right?
Yeah.
Because we will definitely leave some amazing cool stuff behind. If you're a listener listening to this right now and we left your cool project behind, please leave a comment in our website.
And you'll just have to add it to another podcast. Yeah. Another episode.
Yes.
There you go.
Yes. So there you go. I'll have to invite you again, and we have to have a second view. So all the languages, between the languages that we picked up here was in no order of importance: Agda, Coq, Lean, Idris, Isabelle, Haskell, Scala, Crucible, Saw, F-Star, Rust, Python, Julia, Racket, the LLVM, and C#. I think we could even add Java here, because when Java came out, it was this really cool type system that was supposed to be this safe system, safe type system. And in a sense, it was quite revolutionary when Java came out, because it really forced people to really think through what types would match how well typed things should be. It was good. It was very important. But in my point of view, that was not the only reason for the huge success of Java. The JVM absolutely played a very significant role there, because Java just came in a time. I may be very wrong here, but by the research that I've done in the past, Java just came out in a time when portability was still a big issue, and they were like, here is a very clean solution for portability, the JVM. Ta-da! And there we go. We have Java nowadays. It's people complain a lot about Java, but it was cool. It's still cool.
But funny thing is, it's sort of converging a little bit towards Scala. It sees where Scala and Kotlin are eating its lunch, and so it's making small changes to like kind of converge around some of their more functional design patterns.
That's actually a very good thing, because languages have to evolve, and sometimes languages evolve so much that it's time to kill this little little beast that it has become, right?
That is true. Like sometimes, like there's definitely cases where language tries to add a whole bunch of functionality and patterns, but if you're from the PL perspective, you're like, this is all an instance of this one functionality. If you would have added that, you would have had of all these as a derivative. But but you've boilerplated all these things on, and
But then now, in order for you to add that, you have to have this huge dependency graph of how it's going to interact with all your other cool stuff that's already there, and that you cannot by no means break. Otherwise, the language just breaks for everyone. Like you cannot do that. So, in a sense, I think this is the very hot take of this whole podcast. But in a sense, for me, that's where Coq is almost at. Coq is a huge little beast by now. I hope no Coq developers listen to this, but that's kind of the reason. That's kind of low key the reason behind Lean. If you look into it,
Lean is. I feel like in terms of popularity, I think Lean is going to take the younger generation of formal verification people.
You think so?
I see it from like Twitter, like patterns, and quite frankly, how active their communities are in, like in Zulip, for instance. If I leave my Zulip notifications for Lean open, I get like 2K messages a day for notifications. Rather, in the Coq one is pretty quiet. But see, that's also like maybe it's just the platform for a certain type of people. So
in my point of view,
it's not a mailing list. It's not in the IoT whatever.
But here's the thing. Well, Coq also have a very active Zulip. Let's defend my little boy over here. But my point of view, the reason why Lean is so successful, it's growing so successfully, is because they're really good at advertisement. They're really good at marketing. Their marketing is just, they have articles all over the place. They have people are talking very strongly and like voicing their strong opinions about how things should be made, and that draws a lot of attention. I'm not saying this is bad, and especially because I've never written one line of code of Lean.
Oh yeah, me neither. I've watched presentations just to see like what is this thing all about. But yeah, like what you're saying in terms of advertisement, they've had like a couple articles in like Quanta magazine or something like that. That sort of mathy oriented magazine.
Yeah, that was huge.
Yeah, and then they also do things like I think they do more partnerships with like Google Summer of Code and stuff like that to try to get.
They do
more.
really? Okay, so there we go.
Yeah,
they're doing. Yeah, they're playing the right cards.
Yeah.
But okay, I'm done doing the devil's advocate against Lean. Let's talk the good stuff about Lean. Lean. Okay, I've watched a couple of presentations about Lean, and I've actually met Leonardo. He's Brazilian as well, so you know, if a Brazilian meets another Brazilian, we bond right there, like we're friends. But I mean, there are not many Brazilians in this, like going to Popo and this stuff. Like it's anyways.
Yeah.
So I watched a presentation of his, and in that presentation, his whole pitch was based on doing tactics right. So having this whole very cool and good meta language for interacting with your environment, interacting with your proofs, right? And that sounds very compelling, honestly, because yes, if you want to do interactive theorem provers, you need a good way to automate your proofs. You need a good way for program how your proof search, right?
Me, sad face with my Agda.
Really? There's no automation in Agda?
I mean, I don't know. If you're working in Agda, it's rather raw. You're just staring right at like the type theory terms, and at least the way I don't really do tactics. But I'm also not doing big proof developments, so. Yeah.
Oh yeah, they don't have tactics, right? So how can you develop tactics if there are no tactics?
Yeah, it's in that weird space. It's not quite Idris, where you're more of a functional programming language with dependent types.
Right. Right.
But they also, I don't know. I mean, maybe Philip Wadler would be upset with that, because I think he does programming language foundations in Agda, and I think he does try to show. Here's how you could try to mimic or create tactics in Agda. But it's definitely no like certified programming in dependent types. Like it's no like Coq is definitely the winner in that space. And yet I don't know much about Lean, but
that's the thing. Yeah. Like in Agda, if at least to me, it feels like you're programming. It's easier for you to actually run your code, because now in Coq, if you want to actually have a machine executable, then you have to go all through the hassle of extracting your code to Haskell or to OCaml. There are some libraries that you can extract to C, but that's another deal because it's not from the standard library. But yeah, it's kind of feels like a hassle to actually run your code in your machine. In Agda, it feels more natural. It feels like this is more on the programming language side, right?
Yeah.
And same goes for Idris. If I'm not mistaken, that's the whole reason of being of Idris, right?
Yeah.
Which is like, let's bring dependent types to the programming community. I believe I think it's kind of fair to say that.
There's actually a Haskell consultancy, I think they're in Europe, called Tweeg, and I think it's Ryan Ellisberg. I don't know. The person who's working on dependently typed Haskell is with them. He's like one of their senior research scientists or something. And he does a YouTube series where he talks about, I think, working on like Haskell compiler. He recently did one about updates on where he is with dependent types. I think he did a PhD under Stephanie
Werich.
Yeah. But yeah, you said bring dependent types to the industry, and I'm thinking, yeah.
Right. So good thing you mentioned that, because exactly, Stephanie Werich, she was also working into bringing dependent type into Haskell, because now then if you put dependent types into Haskell, then you can show that, I don't know, that you can do dependent types anywhere. I believe, I don't know, because Haskell is the most successful functional programming language, right? Like that's
Well, but Simon Peyton Jones also says to avoid success at all costs, right?
well, so Simon Peyton Jones failed. Sorry to bring it up to you guys, but yeah, he's a failure. No, I'm kidding.
Yeah.
So actually, what happened to that project? Is it gonna happen? Are we having independent Haskell?
It sounds like it's still months, if not like a year away. But the part that he said he was kind of like tinkering.
Come on, I think I looked into it like 5 years ago, and they were saying, okay, we're 1 year away. We're 1 year away. Come on.
Yeah,
is it happening or not?
It's like that quantum supremacy stuff or whatever. No, but so what he said is he said that the GHC is currently in a hard state right now. So when we were talking about like bolting features, well, now Haskell's kind of got linear types and stuff like that they need to make work with dependent types. And he said that there's cruft in GHC that makes it hard to work on those development. It's not very ergonomic to kind of go in there and work on these things. So I think the goal kind of at the moment is kind of from what it seemed from what he was talking about is make it easier to work in GHC, but also figure out how it's going to work with these linear types that have been added.
Well, one thing is for sure, adding dependent types like that to this huge type system that Haskell is already sounds like a lot of work. Yeah. Not only because dependent types is tricky, but how all these moving parts interact with each other. There's that. Yeah.
Good luck to them. They're fighting the good fight.
Good luck for them. Yes. We are all rooting for them. Yeah. Go.
Yeah.
So we can move towards talking a little bit about some projects in some of these languages that we have mentioned. So
yeah,
I think. Okay. So we talked a little bit about Coq. We talked a little bit about Lean. We talked a little bit about Agda, about Scala, about Haskell. There's not come on, we don't even have to talk much about Haskell. Everyone here is more than familiar with Haskell. I hope, or I believe. And if you're not, go learn Haskell, man. You're wasting your time.
It depends. I mean, Haskell's all those different languages depending on what extensions you add.
Well,
I was about to say, they're doing these yearly releases on what is Haskell 2020, what is Haskell 2021 to try to standardize language extensions on a yearly basis. So joke is to me like Haskell seems like it's multiple languages.
Exactly. Actually, my former advisor when I was doing my undergrad, he was very upset with Haskell. He was like, I love Haskell and everything, but language extensions are just killing the language. That's his opinion.
Yeah.
Because I mean, that's the thing. In the end of the day, you start working on a Haskell project, and then all of a sudden you have to learn all this subset of a language. You have to learn a lot about a new part of the language just because it's a language extension, and everything can change all of a sudden. A lot changes with language extension. So I kind of get his point. He has a point. It's tough. It's a tough place to be at. So that's a problem for the next generation of programming languages to take care of, I believe.
Yep.
Because in a sense, Haskell is doing great with all those language extensions, and we all love Haskell in a certain degree.
And it's proven to be malleable.
What do you mean?
You've seen the implementation of liquid types, refinement.
Liquid
refinement types, linear types, dependent types. It does its good job of being a good test bed for research. Anyway, sorry, you want to transition off Haskell? We can do.
No, we're coming back to this. I actually want to talk a little bit about Liquid Haskell later on, because before we transition, talking a little about the projects, we talked about all these cool languages, but there is one language that is quite dear to my heart. That we don't talk that much. It's kind of like a forsaken interactive theorem prover that is out there and far away, and I feel like people just forget about Isabelle. Isabelle is beautiful. Isabelle
Really?
has such a beautiful automation of the proofs,
Really?
man.
What would you say some of their core design philosophies are?
Sledgehammer. That's
Sledgehammer,
it.
there you
Sledgehammer.
go.
Yes.
Yeah.
Let's open a lemma. Let's try it,
Yeah.
and let's sledgehammer.
Nice. Smash it to pieces.
So-
Nice. Yeah.
So Sledgehammer is a automation tool. That's it.
Mhm.
Basically, you have your lemma. You start your lemma. You want to prove something, right? I want to prove that, I don't know, that my function terminates when I input 5 and it terminates with output 7, and let's do some induction on this. So you do your stuff over there, and then you just hit Sledgehammer. And what
Nice.
Isabelle does is really cool, because it takes that proof state right there and feeds to an SMT solver. And he's going to do all his SMT solver magic. And boom, it yes or no. And it can even give you counterexamples with Nitpick, which is another tool that is for trying to find counterexamples. So Isabelle is really cool. Isabelle is nice. When I was learning this, it was 2014. Oh my god, I'm getting old. But I was in Australia. So the people who actually uses this more is either in Australia or Germany, because of reasons that are far, I don't know.
Well, wasn't that Cell 4 project based in like Australia or something like that?
Yeah, exactly. They're at NICTA. So I could do a internship over there. And at the time it was called NICTA, but now it's called Data 61. They changed their names. And they were doing this whole formalization of a file system. Oh, not file system, like the whole OS. So SEL4. And this whole formalization is made in Isabelle. And it's really cool, and it works. They have drones running on this, and it's amazing. And people there is very smart. Actually, one of our coworkers, at Galois, if you remember Daniel Matichuk.
Yes, Dan.
He was from there. I actually turns out I actually met him at Sydney, like probably like one time. We met each other like one time.
Yeah.
Oh man, I miss those people so much. We would go out on walks with his dog. Oh my god.
Yeah.
So, anyways, Isabelle is a really cool interactive theorem prover. And yes, people at NICTA, at the time it was now Data 61, do some really cool stuff with it. But what I wanted to get at is, when I was learning Isabelle, I felt that in relation to Coq, it was such a nicer introduction to the world of formal verification, to the world of interactive theorem proving.
Yeah.
Because automation plays such a big part that, like a lot of the times when you're doing a proof in Coq, it just feels like you're literally having this blood duel against your computer to make things go through. Like sometimes it's something very dumb, like 1 equals 1, and you don't know what to do.
It's that, what is it, the 0 plus 1 equals 1, or it's however you define your addition. You have to actually,
So, for example, there's that lemma that 0 plus m equals m plus 0. It's a hard lemma to prove in Coq. It's not trivial. It's not straightforward.
You know what? I actually attended recently. There was this mini conference from the Broad Institute and I think MIT called Formal Methods for the Informal Engineer.
Okay.
So they did introductions to Z3 and Coq, and people really like Z3 because they're like, man, this thing is smart enough to handle all the really, like, I can just throw my queries at it, my like things, handles it. They go to Coq and they're like, they see this exact same problem with like the 0 plus 1 or 1 plus 0, those sorts of lemmas, and they're like, well, why would anyone use this tool? So I wonder, like, so in Isabelle, like when you learned it, how quickly did that automatic like theorem proving stuff like surface in the tool?
So that's the thing. The whole tool is built around to have a nice straightforward implementation of just giving it to the SMT solver, right?
Yeah. Yep.
So the whole idea of this interactive theorem prover is to have a good interface with the SMT solver.
That's
so
interesting.
even the IDE that you use for it is built around having a good implementation for the SMT solvers, and even like using multiple cores so that it can speed up to find your proofs faster.
Nice. Very nice.
And it feels so straightforward. It feels like you are working with the tool, not against, which is what happens many times with Coq when you're learning.
And to be honest, I think if people are going to see more industry adoption of these tools, I think it's those kind of ergonomics that people are going to want to see wider adoption.
Definitely.
Yeah.
And one of the big ergonomics that I believe it's going to be the future, it's going to be how these tools are going to come in practice for the industry, is definitely integration with SMT solver, like automation, because proofs are real boring. Proofs are hard. You need PhD people just to do the proofs. Like, no, this is not how the real world works, right? Like, you need faster. You need things to be compatible, retro compatible. You know, like I cannot stop and do a proof that will take me 6 months to do for every iteration of my software.
They're expensive.
That's impossible, right? No, exactly. So we need better automation tools. We need better tools to make it easier for us to do so. And another thing that Isabelle have that Coq kind of struggles is an archive of proofs. So in Coq, when you're developing, when you develop something and you need to go outside and look for, you know, like, did someone already prove this? Did someone already implement the same problem that I'm having? You cannot find. It's hard to find implementations that go well together. And a big reason for that is the use of axioms. There are a lot of axioms in Coq that just don't go together. So if your project uses an axiom, you have to be very careful if you can actually import that project, because it can actually make your whole theory inconsistent, right?
Yeah.
And I don't know how they deal with this particular problem in Isabelle, because I'm pretty sure they also have axioms. But they have this really nice archive of formal proofs. And I actually have their website open here. Let me pull it up. In this website, they have 160,400 lemmas proven about all cool facts in math and computer science. And they actually have an index here for the most used ones. So like list index, co-inductive collections, and regular sets, Landau symbols. Do you know what Landau symbols are? I just looked it up.
Yeah.
I just looked it up. It's like big O notation for big numbers. That's what I could get. If I'm wrong, please, listener, please correct me later.
That sounds right. Yeah.
So factorization, abstract rewriting, automatic refinement, Jordan normal form. What is that? No idea.
Some matrix thing, I think. But I have a question. Is this like? Do you know what Hugel is for Haskell?
It's better than Hugel. Is that true? I'm not sure. It's similar.
Yeah,
it's similar.
But it's kind of like you can search a type to find like a witness to the type or something like that.
I'm not sure. I never use this.
Yeah. Well, yeah. I mean, yeah.
You can definitely search some cool stuff in here.
That's awesome.
And I mean, the most important part is that there is this active effort to put the developments in one place so that people don't have to redo their work. And this is always very important for software development. Therefore, it's also important for proof development, for sure.
Absolutely.
And that's the thing I kind of feel in the Isabelle community, is that they're very concerned and they're actually thinking about what does proof engineering means, because they are doing some big ass proofs, man. They're doing some very big proofs.
Yeah.
And okay, so
that's
just to wrap it up, talking about Isabelle, that is like it's really annoying me right now, is that I never there's one important fact about Isabelle that I didn't mention yet, and I think it might be kind of a deal breaker for some of the people.
Yeah,
but I'm not sure if it's that much of a big deal. But hear me out on this. Isabelle does not have dependent types.
Oh. Interesting. I mean, right? I guess if you're going to throw stuff at an SMT solver, you're not going to, that's not really, a decidable thing. So
Exactly. And so as you can see, it's even that is well thought to have a good relationship with SMT solvers. But that's the thing, right? Like So the big question is, what are the things that we can do in say Coq, like this full dependent type language, that we cannot in Isabelle? And
Mm-hmm.
I don't know. I have no idea. Nobody, like, we can do a lot of really cool stuff with Isabelle, that's for sure. We have this OS, we have this file system called Cogent as
Yeah.
well that they also developed there, and it works, and they have a sound way to show that things work, you know. So
So I didn't know about Isabelle, but I did watch some presentations about F Star recently, and it did seem that they're kind of like trying to go for a similar sort of design space with trying to have like an SMT Oracle as something that you would actually call frequently, but still also be a dependently typed language.
right,
Yeah.
yeah, that's kind of the I'm not very familiar of how F star works, but yeah, from the little things that I've seen here and there, it seems a very similar way. But it seems to me that F star
Yeah.
leans more towards being a programming language than a theorem prover, right?
Yeah, well, I think it's one of those. I don't know if it's Lean or F Star, but I'm pretty sure one of those two bootstraps themselves. Like they implement the. I I think maybe I'm not sure if it's the whole like from the kernel outward, but I think one of them definitely implements a substantial amount of its own code in the language.
Wow.
I'm guessing that
Yeah,
must be
yeah.
F Star. Yeah. I don't know if that. I mean, I don't know if that really gets you much. I mean, it's an engineering feat, maybe, but
Right. No,
yeah,
yeah, that's
yeah,
actually kind of that's how you build compilers, right? Like that's the only way for you to actually build compilers is to when you're done, you'll have to have a compiler in your own language. So yeah.
yeah. But yeah. I don't know if I guess I don't know if many theorem provers like have that as like.
I believe Agda
Mm,
has a big chunk in Agda. I'm not sure if
mm,
it's all of it,
yeah.
but they have some cool stuff written in Agda as well.
Mm,
Maybe they could do it for Coq with the new things. That would be, oh my god. I am tired just to
yeah.
think about it.
Yeah. And it doesn't to go back to it, doesn't have some integrations with using SMT solvers in Coq now that are a little bit more ergonomic or.
Yeah, there was this hammer tool that came out, what, 2017, Popple,
Mm,
and that was kind of their idea.
yeah.
Like pretty much implementing Sledgehammer from Isabelle, but in Coq.
Yeah.
But I don't know. It seems like a very hard problem, honestly, because how can you encode your proof state
Yeah.
in for an SMT solver, but then the SMT solver just gives you back yes or no. You know, it doesn't give you the proof. Doesn't It's classical logic, and that's one important thing about Isabelle as well. Isabelle is classical logic, so it doesn't extract
Oh,
things for you. That's
I
important.
did not know that. Yeah.
Yeah.
Interesting. Cool.
So actually using these things in Coq sounds a lot harder
Yeah.
because you still need the actual proof, right? You still
Yeah.
need the actual what's the word? It's the
The witness, the
witness
witness
exactly.
proof. Yeah.
Thank you.
I'm sort of interested in. I don't know how well their efforts are going, but in the Twitterverse, I do see more people trying to apply like machine learning type search problems to find proof terms.
Yeah, it actually sounds like a very good question, you know,
Yeah.
actually. Yeah.
So, I mean, I'm not a big machine learning person myself, and I don't know how well they're capturing the domain, but I do see more chat in that space as maybe some sort of like ML search based proof tactic.
Okay, we are already 45 minutes in this podcast. Maybe with some editing, this is gonna change a
Yeah.
little bit. So we still didn't start talking about the different
Oh, sure.
projects that
Yeah.
like our whole planning of the episode went
Yeah.
downhill because we started talking about like we got super excited talking about these cool languages and it's
I
just
feel like
fine.
we're just recreating Andre Brower's every theorem prover seminar series, but
But
podcast style.
yeah, kids version, right? Because
Yeah.
we cannot compare with those
Yeah,
king.
no. Yeah, wonderful seminar. I hope it's on YouTube. I think it might be.
So
But
what's the name again?
it's Andre Brouwers.
Right.
Sorry if I'm mispronouncing the name, but I think it's called Every Theorem Prover, and he did that.
Every Theorem Prover, right, right.
Yeah.
I was following you for a little bit, but then like I don't know, it was just some random times that I'm like,
yeah, that was a lot of catering to European time zones.
Okay, so let's start talking about the projects. How about start with Agda, because that's how our list was made.
Sure.
So some cool projects that we can find in the Agdaverse, Agda universe. Yeah, Agda have universes. So my claim
they do. Well, universe at what level?
Omega.
Yeah, the hardest part about working in Agda is those dumb universe indices and trying to be like universe polymorphic definitions. It's a pain in the butt to work with.
Dude, Cox, I think universes are just a pain in general because So first project we have here is Agda categories. What's that?
Yep. So this is a really awesome library. Basically, it is a library for category theory that's very, very extensive, and their definitions they have definitions for so many different things, and they do a lot of really good work to make a lot of really good engineering work to make the definitions nice to work with. Like categories are parameterized by some notion of equivalence. So you could work with definitional equivalence if you want, so you get some kind of pre-category, or you can work with something a bit more advanced. I've opened up that library, toyed around with it, and it's just really fun. It's really beautiful, especially like everything is all out there in Unicode. They're also on Zulip too, and they're really good community. I've chatted with a couple of people on that one.
And on top of that, you also can build the hot library? Is it built on top of this? Maybe because
this is actually a tangential development. But in terms of hot, though, Agda does have a really, really nice cubicle type theory library.
Right. They could implement it done right.
Yeah. They also have something really weird too. They have a bit of modal logic or modal type theory. They have a modality, some kind of flat modality in it. It's one of the special language things you can add. Mm-hmm. Don't really know what that is, but I've seen papers floating around for modal type theory. I don't know if anyone out there is interested in that kind of thing. Just throwing it out.
Right. Yeah. Modal logic is something that sounds very interesting and with a lot of applications. So basically, if I'm by no means, I've never actually worked with it, but if I understand correctly, the whole idea of modal logic is that you can talk about contingency and necessity. So like some stuff you must and some stuff you can, right? Something along those lines.
Yep.
And so that's kind of the idea of modal logic. And apparently it's kind of a good way to model resources. And I think maybe there is some comparison between modal logic and linear types. I think it's similar in a way, but I have no idea what I'm talking about here now. Like,
yeah, I have not read enough in that space to say anything intelligible, but yeah. There's some I know there's some cool papers out there.
Yeah. And okay, so Agda categories, hot, cubicle. There is observational type theory. I have no idea what that is.
That one is, I back when I was at Purdue, Ben was trying to show me a paper about observational type theory, and it was sort of in our discussion trying to lead up to hot, but I was too young to understand what homotopy type theory was, and still am. Someday I'll be old enough. But
so that.
Yeah, it's one of these type theories that is focused on a different sort of representation of equality, if I understand correctly.
Mm-hmm. Okay, fair enough.
Yeah,
and another cool, very cool thing that's also implemented in Agda. I don't know if you knew that, but Cedil is implemented in Agda. Did you know that?
Yeah. There's the I think the Iowa Agda standard library or something like this, and
so they use that to implement Cedil. And the idea was that maybe someday they would be able to formally verify the Cedil code base. But I don't see that happening. Like a theorem prover gets very, very hairy very quick.
Yeah.
So, but well, for those who doesn't know, Sadil is this other interactive theorem prover that is
Mhm.
supposed to have a smallest calculus possible, like as
Yep.
small as possible. There is no other theorem prover as small as Sadil.
Mhm.
Let's stop there, and
Yep.
you can actually do some cool stuff there. That's kind of like the research question, like what are the cool things we can do, even have this very small, dependent type system. They don't have universes, so there's some stuff that you definitely cannot do.
Last time I checked in on that line of work, I think one of the big things about Sedil is they were able to derive their own induction principles for
Yeah,
a
yeah,
large class
it comes
of
for
types.
free. Yeah,
Yeah, without having to do something more bolted on the side, kind of.
I don't want to spend too much time talking about this because I'm definitely have intentions to bring Chris Jenkins to have a whole episode just about
Oh
Sadil. I
yeah,
want to have a
that
whole episode about everything,
100%. Yeah.
So moving forward,
Yeah.
let's talk a little bit about some cool projects in Coq. And
Yeah.
of course, we have to start with the four color theorems because that's, staple. That's what
Oh
made
yeah.
Coq famous to begin with.
Mm.
That was the thing that brought attention to interactive theorem provers to begin with, right? The four color
Yeah.
theorem.
Oh, I was about to say, it's funny. Like that win has lasted them a long time. Like that little tidbit of
Until now, yeah,
yeah,
until nowadays, we use it as a reference of the cool stuff we can do with interactive theorem prover. And the reason,
yeah,
I believe, the reason for that is that this was an open question for a while,
yeah,
and people didn't have a good way to even reason about it, and came
mm,
these amazing people and could actually not only find a proof, but with the help of computers, right, with the help
oh yeah,
of a language. And they
mm,
did it, they happened to do it in Coq, which was really
yep,
cool. And then, of course, we also have to mention CompCert for Coq, right? So CompCert is the
yeah,
C compiler, and huge, almost everything of CompCert is formally verified. Last time I checked, I'm pretty sure about this. I'm like 95% sure that there is only this one part that is not formally verified, which is the parser.
yeah.
And there are a lot of benchmarks on, comparing different compilers for C, and CompCert was the best one for them, the best. The only
Nice.
problems they could find was actually in these parts that were not verified, meaning the parser
Well, I mean,
parts. Yeah.
isn't the tough part there too that the C language like has some standards, but there's still like undefined behavior in some of those standards.
Yeah.
Yeah,
Dude, that's another plan I have, to invite someone that knows C very well, just to have a
yeah,
whole episode just roasting C because of those undefined behaviors. I mean, dude, it has so many undefined
yeah,
behaviors. Ugh,
yeah,
it hurts. It hurts.
yeah. Watch out, though. We lose our C people. Everything else is going to crumble out from underneath us.
No, we're gonna have Rust. Rust is
Yeah, we'll
coming
have
along
Rust.
the way.
Yeah, since Mozilla, the Mozilla team for Rust basically just separated, but it seems like Microsoft might be kind of like taking them on and facilitating its
Mm,
growth. Yeah,
that sounds. I like that idea.
yeah,
I don't know. Just I'm biased here. I really like the idea behind Rust. They're using some really
yeah.
cool type system stuff. So
Oh yeah.
there is another cool thing, another cool project in Coq, and I don't know if we put it here just because we've been reading papers about this recently, but
Yeah,
it feels very biased. It feels very
yeah,
biased to have interaction trees here.
yep.
Do you wanna explain the listener what interaction trees is all about?
I think so. The why I put interaction trees is one. I recently read a paper on it, but I also think that it's this really elegant way to represent a program and its semantics. So basically, what the core of data type of what an interaction tree is a co-inductive tree that you can use to represent divergent programs and
Mm-hmm.
the series of effects that those programs emit. And there's a whole paper on interaction trees and a new one as of Popple 2020 that combines them with Dijkstra monads. Um, that
That was
it
21, right?
actually, yeah, it might have been.
Yeah, it was
Yeah,
this.
yeah,
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 it
yeah,
was right
yeah.
here.
because the interaction trees paper was that 2020? Am I
that was
lost in the
2020.
I'm lost in the COVID time vortex?
We are still in 2020.
Yeah,
I definitely agree with you.
yeah, yeah. But yeah, I think I think that's an interesting data type and paper to check out. How you can model.
Non-termination.
Yeah.
Yeah. And another
And
cool thing that I feel about interaction trees is that it feels like it can provide a nice framework to reason about equivalent programs, something along those lines.
yeah.
Yeah. And the next one here, of course, I had to bring this up because it's what I've been working on recently, which
Absolutely.
is Coq of OCaml. And
Yes.
basically, what Coq of OCaml does is it's translating OCaml to Coq. And this is being developed by Nomadic Labs, which is the company I've been doing my internship last summer, and I'm still working, kind of doing work for them, but like I'm just wrapping up some code, so that's fine.
Nice.
And yeah, I mean, I want to publish out of this as well. So like, I need to have something good out of this. But the key idea of Coq of OCaml is, okay, so Nomadic Labs is behind the Tezos cryptocurrency. So they have this whole language for smart contracts in the middle of their implementation, and they want to reason that on the correctness of those things. So in order to do that, the idea is to translate from OCaml to Coq, and in Coq world, we have, we can prove things. Voila. So it's a really cool project. I think we can stop talking about Coq here. Everyone is probably tired to know all the cool stuff around Coq.
So I'll say one thing that I've seen that's sort of interesting is that in terms of formal verification trying to enter the industrial market, cryptocurrency seems to be a big space. I mean, but I mean, a lot of these shops have like these smart contract languages, as you said, with Nomadic Labs and Tezos, and so it's provided another way for formal verification to enter the industrial market. I mean, previously you have like shops like Galois where it's like, sort of like defense contracts or mission and safety critical systems. Yeah, now we're starting to see a little bit more, I guess you'd call it finance sector, something like that.
Yeah. I definitely agree with you. Like, it's actually something very excited to be talking about because this cryptocurrency stuff has a lot of money. They're bullish on what formal verification can bring to the table, because if there is one thing that I want to formally verify, it is my money, man. I'll tell you that. Because dude, I don't trust my shadow with my money. I mean, anyways.
Nice.
How about Lean? What cool stuff? We didn't. Lean is so new. Lean is such a young boy.
I know, and yet it's got all this attention. I don't know, maybe this is being naive with the history, but what was before the Coq theorem prover, right? Like, was there something that was just that big, and then kind of like Coq came around, and now?
Well, yeah, I feel like it started getting some attention after the four-color theorem, and that was made in Coq. Yeah. So Coq is the one who made things shine. But we definitely had Perl. We had some other theorem provers that I cannot even remember, but we definitely had a couple of different theorem provers.
If I recall, there's something like MetaMath. I don't know if that was like a research program or if that was a tool. I can't remember. But, with Lean, Kevin Buzzard, who's kind of like, a big spokesperson for Lean and trying to get Lean into early math education too. They're going after like, the big math prizes like Langland's program, I believe. And that's I don't understand too much about it from the outside, but I do know that it is like one of these you could say Hilbert-like problems of our current generation. It's like this bridge between geometry, arithmetic, and algebra that's proven to be fruitful, apparently. And so they're trying to do some of that work in Lean.
Ooh,
yeah,
hot,
I don't.
Hot.
Yeah.
Is it them? So I have here this website called awesomeopensource.com. And I can see here that they have this very big project called MathLib in Lean. Yeah. Do you know if it's Kevin Buzzard people who's behind this one?
I think it is. And when you were talking about with the Coq theorem prover that they have this archive of existing proofs, I think this is sort of their analog version, or like, their analogous version. This Mathlib is what I think is even trying to be used in some undergraduate math education or something like this.
Yep. Yeah, well, actually, they have some really. It's quite big, so awesome. Oh no, there's something else. So Lean Time, so it's a Lean project management system. Lean 4 apparently uses some Lean. I don't know how much Lean. Cosette is an automated SQL solver in Lean. This is amazing. This one sounds really cool.
I was about to say, an interesting place that I've seen some functional programming and applied category theory is actually in databases recently, and there's been some commercialization in that space.
Oh yeah.
Yes, there's this place in San Francisco called Connexus AI, and they focus on categorical query languages, which is using category theory as the algebra of relations in like set theory is like, it's mathematical like denotation or something like this. Then category theory is sort of like the denotation of this kind of query language. And yeah, it's been interesting to see. It just came out of MIT math department and has been spilling out into the applied category theory space. It's sort of interesting to see how they think about data differently. For them, a schema is like a small category, and an instance is like a functor into set.
Oh my god! Is there anything you cannot apply category theory to? Come on.
No. Well, now applied category theory is its own sort of mini sub-discipline now. Yeah, it's really interesting. Cool. Yeah.
So moving. Oh, actually, so I think Mathlib is not from Kevin Buzzard. I think the name is
really?
Project Xena or Shina.
That's
Xena.
Okay.
I don't know. Yeah. Well, let's stop Lin here. You had your moment of you're shining too much. Go away, Lin. Next. What about Idris? Could you find any cool project? Like, what's going on in Idris land?
I don't know, but I'd say with respect to Idris, I've almost wanted to use it because I get frustrated with Agda universe levels, and I just want to program independent types. Like,
screw this, let's go to Idris.
Exactly. It's like, I don't care. Just collapse the whole universe to set and set. I'll just work in that.
Whatever.
Exactly.
You can do that with Clock. There is a compilation flag that you can do it. So yeah, True. Actually I have the awesome opensource.com for Idris as well here. And one thing I forgot, there is the successor of Idris coming out, which is Bloodwen. So
that is completely new to me. This is like beyond Idris 2 kind of development.
No. I believe this is right before Idris 2. Okay. Now it's called Idris 2. I'm pretty sure. Yeah, so I don't know exactly what are the cool things that they solved or implemented, but it seems really cool to me that Edwin Brady decided to start from scratch and instead of just build on top of it. And it's good as well because it feels like it didn't have major adoption yet. Like, it was pretty young and small enough so that he could just throw everything away and start from scratch correctly. And so apparently, there's some software foundations is always very hot, and people will always work with software foundations because it's a beautiful, beautiful book for learning interactive improver dependent types, or
it's all about IMP.
IMP all the way down, huh?
Yeah. Yep.
So they also have this project here in Idris called TypeDefs, which is a programming language agnostic type construction language based on polynomials. I have no idea what that means.
Oh, interesting.
Sounds cool. Sounds super cool.
I wonder if that's like polynomial functors and like
gosh,
sort of like Connor McBride's containers sort of library. Maybe, I don't know. I'm wondering if that's sort of a similar thing.
Let's look into it later.
Yeah.
There is Idris JVM. This one sounds really cool. JVM bytecode backend for Idris.
Oh wow.
Lightyear. Oh, this one sounds really hot. Lightyear parser combinators for Idris. So the other day I was talking with with John Serracino here at the podcast. I think podcast
Hmm.
number 2, and he works with parsers, and parsers combinators are the cool thing happening in parser
Yeah.
land. So
Yep.
it's really cool stuff. Oh look, they also have category theory. Oh, this one is very impressive.
Yeah.
I am I
There's
wasn't expecting to have category theory in Idris.
So actually, I think that one is maintained by a small consultancy and research company called Statebox. I'm pretty sure that they're in that. They do courses for category theory for engineers, which is kind of interesting. Yeah.
Okay. Yeah, there are quite some cool companies going on that works with functional programming. So you are working on 47 degrees.
Yep.
There is Galois doing some work in on that field. There is Data 61 that we mentioned. What
Yep.
else?
There's a couple Haskell shops. Sarakel, I believe.
What is
I don't know.
that? I don't think I've ever heard that one.
They're a Haskell consultancy, and I believe it was either them or there's another Haskell consultancy called Type Level that release a lot of blogs about what are linear types in Haskell and how to do profiling of GHC and stuff like this.
Hot.
Yeah. Sorry, I think I think I misspoke. It might have been Twig. I don't know. It's either Twig, Syracuse, or Type Level. There's a lot of these Haskell consultancies flying around that have really really nice blogs.
That's a good sign in my point of view. Good thing.
Yeah.
I was looking into, I waste a lot of my time on Reddit.
Yeah.
Most of people here, I feel they waste their time on Twitter, but I don't know. I just cannot do Twitter. But I spend a lot of time on Reddit, and there is Jan Yang that was organizing some really cool talks called PL Talks. I'll leave the link in the description. It's basically a Git on her GitHub. So github.com, Jan Kassar PL Talk. And they had some really cool invited people over there. But the reason why I'm bringing this up is because this Jan Yang, she just recently opened a really cool startup, and the whole idea is how to build APIs properly. And the name of her startup is Akita Software. Akita Software.
Interesting.
Yeah,
Nice.
Yeah. Sounds really cool stuff. Oh, there is this one thing that I believe you can talk a little bit because you were looking into this.
Yep.
What's the deal with Aran Theorem Improver?
Yeah. So a coworker at 47 and I were looking at theorem provers and stuff, and we took a little dive into Arend because he primarily works in Kotlin and I work in Scala during the day. So like, all right, what does JetBrains have in this space of theorem provers? So Arend is it's pretty nice. It can implement it has an implementation of cubical type theory, but it doesn't feel like a well polished theorem prover.
Come on.
Yeah.
You're supposed to talk good things here, man. Come
on. Yeah. I mean, okay. I'll say. I mean, you're comparing it to like the big ones here that we've had on. With Lean that has like Microsoft money. I mean, come on.
Yeah. Come on, no, come on. This one is in JetBrains. Come on. JetBrains is the one IDE nowadays, right? Like, who does not use IntelliJ? Everyone uses IntelliJ. IntelliJ is the one IDE out there nowadays.
Yeah.
Come on.
Yeah, so I don't know. It was an interesting. In a lot of ways, theorem provers are kind of like these like research artifacts that they're hard to install on your machine and whatnot. With Arend, really simple. It just basically had like this IntelliJ plugin, and you had all the support of the editor was already there because that's just what JetBrains does. So I take my I'll give them credit for that.
Okay, there you go. It's a really nice. It's a maybe let's say it's a prototype theorem prover.
Yeah,
but it has a very nice interface because of JetBrains.
I would also say that if you want to play with cubical type theory, I'd recommend either that or Cubical Agda. And they both, I believe, they implement different versions of cubical type theory, if I recall correctly.
All right.
Yeah.
Dude, I believe that we can stop here. We talked about a lot. There's a lot we left behind.
I
we
know.
can we can most likely have a second episode, the second version of this episode where we
Yeah.
continue, because we
Yep.
basically we basically talked today about the theorem provers, but we
Yeah.
still wanted to talk about the non-theorem provers of
Yes.
functional programming languages
That's
with
true.
some cool stuff, but we didn't have the
Yep.
time. We're actually pretty much like almost 20 minutes in.
Okay.
But well, this was very productive. I'm very happy with this episode. We talked
Oh
about
yeah.
some really cool stuff.
Wrapping up.
Is there anything do you wanna bring it up that you think it would be important that we didn't have the chance to talk about? This is your time to shine, man.
So I guess I'd like to say, COVID's been a hard time, and it's made us all feel isolated. We're all at home, but I will say this: if you're listening to this podcast and you want to learn more, go and check out all these beautiful, beautiful seminars of functional programming, type theory. There's like academic seminars like the Strathclyde Mathematically Structured Programming Group. There's series about theorem provers. There's like what 47 Degrees does. There's like 47 Academy if you just want some functional programming knowledge. There's all these beautiful resources out there, and I think we're living in this really weird time where we just have this big boom of awesome online interactivity. And while COVID sucks, I think I'd say take advantage of that. Yeah, maybe I can like work with you and post some links to some cool stuff.
Yeah, so that summer school that I was talking about, it's called Midlands Graduate School in the Foundations of Computer Science from 2021. It's going to go through the 12th of April until the 16th of April. So if you're interested in this sort of stuff, they're going to have classes on category theory, type theory, proof theory, homotopy type theory, inductive and co-inductive reasoning with Isabel Hall, effects and call by push value, formal modeling and analysis of concurrent system. Those are the classes they're having. Very, awesome very stuff. Cool stuff. Mm-hmm.
Absolutely.
So, yes, I definitely agree with Eric. Take full of advantage of us being in this virtual era where we don't have a physical shape anymore and everyone is just a Zoom image.
We're all the citizens of Zoom. Also, there's also this podcast, Type Theory for All, I heard you could listen
to. You should definitely listen. Yeah. If you haven't checked that out, I don't know what you're doing here.
Yeah.
So thank you so much, Eric, for being here. Absolutely. I hope we can do this again in the near future.
Anytime. Sounds good.
Good night. I hope you guys enjoyed this episode as much as me and Eric enjoyed recording it, because as you may have noticed, we actually had a lot of fun coming up with here. However, we are kind of low-key afraid that we made some major mistakes during this episode because we were talking about some projects that we don't have any expertise in. So, if you could notice any major mistakes that you would like to have amends, please leave a comment in our website www.typetheoryforall.com and I will make sure to make the proper amendments in the next episode. Thank you so much for listening. I hope to see you next time.